Alright, hello there lads, this is our amazing presentation on the development of atomic structure. We couldn't be bothered to stand up and talk to you, so we used this text-to-speech dude. Enjoy. Every atom is made up of a nucleus consisting of protons and neutrons surrounded by electrons. The protons give a positive charge, the electrons give a negative charge, and the neutrons have such a small charge it can be said that they are neutral.
How did this happen?
John Dalton had a theory. It was an atomic one. In the 1800s, he did experiments to find out some atomic weights. Dalton concluded that all matter is made of atoms. Atoms cannot be broken down into a simpler form. All the atoms of a particular element are the same, but they are different to the atoms of other elements. Atoms are rearranged in a chemical reaction, and also that compounds are formed when two or more elements are chemically bonded. But wait, there's more. In 1897, J.J. Thomson discovered the electron, showing that the atoms contained smaller pieces. Before the nucleus was discovered in 1914, scientists didn't know that atoms contained electrons. Thomson developed the plum pudding model. Atoms could be described as plum pudding, with positively charged matter evenly spread out, like it is in a plum pudding, and the electrons would be buried inside, like plum.
Plums, 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 plums.
It was due to Rutherford's discovery that the plum pudding model was no longer accepted. Rutherford decided to test Thomson's hypothesis by performing his own experiment. He called it the gold foil experiment. He wanted to see if J.J. Thomson's plum pudding model was correct, and if it was, he reasoned that the mass of the atom was spread throughout the atom. In the experiment, he shot high-velocity alpha particles, helium nuclei, at an atom, and there would be little to deflect the alpha particles. He tested this with a thin film made of gold atoms. Most alpha particles went straight through, but, to his surprise, a couple of particles rebounded backward. The deflection of these particles were not as consistent in Thomson's model. This is why Rutherford discarded the plum pudding model. He concluded that the only way that alpha particles could be deflected in the way he saw was if the mass was concentrated in the nucleus. His discoveries led to him developing the planetary model of the atom.
Wow!
Niels Bohr was a student of Rutherford's. He developed a new model of the atom and proposed that electrons are arranged in circular orbits around the nucleus. The model can be summarized with 3 points. Electrons only occupy certain stationary orbits. Energy is absorbed when an electron moves from a low orbit to a high one, and each orbit has an energy associated with it.
Hey, that's pretty good.
Radiation can be harmful, but it can also be useful. The uses of radiation include smoke detectors, paper thickness gauges, treating cancer, and sterilizing medical equipment. Nuclear radiation comes from the nucleus of an atom. Substances that give out radiation are said to be radioactive. There are 3 types of nuclear radiation: alpha, beta, and gamma. Radiation can be absorbed by substances in its path. For example, alpha radiation can only travel a few centimeters in air. Beta radiation travels tens of centimeters in air, while gamma radiation is able to travel numerous meters. All types of radiation become less intense the further the distance from the radioactive material. As the particles or rays become more spread out, the thicker the substance, the more the radiation is absorbed. The 3 types of radiation pass through materials in different ways. Alpha radiation is the least penetrating. It can be stopped or absorbed by a sheet of paper. Beta radiation can penetrate air and paper. It can be stopped by a thin sheet of aluminium. Gamma radiation is the most penetrating. Even small levels can penetrate air, paper, or thin metal. High levels can only be stopped by numerous centimeters of lead or concrete.